out in the space. So if I look at pictorially up here, if I have an object in here and I radiate it from the sun, I will get a certain amount of radiations. Once I double the distance, I will get only 1/4 of it. If I triple the distance, I will get 1/9 of it. So you can see the radiation decreases by the square of that number. Okay, why is this important? For extraterrestrial things, this is very important. For us, it's not. Okay. Now, when we look at the, did I confuse anybody here? I hope I didn't confuse. All this is, look, from your point of view, is the farther I move, the less radiation I get. That's all. Okay. That's from the, but notice now from this particular things how important is the area, because remember, the amount of radiation that you get depends on what? On the area that you put. Okay. And what is the key things? What do? We're putting a plate we're putting a plate in here, we're sticking out the sun, and we said, okay, capture the amount of what? Of radiation up here. And this particular plate up here has to be what? Good enough to capture as much of this radiation as possible up there, and transform that amount of radiation into what? Into electrical energy. And right now, at the present time, our solar panels are what? How efficient are they?
20%.
What does that do to your eyes? When you look at your solar panel, the actually radiation you get is actually what? Reflected radiation. Okay? When you look directly at the sun, and one of the things that actually is mentioned, don't look in the sun, because now we're going to go a little bit, the actual spectrum from the sun is not only, it's several types of radiation in a different spectral thing. So you don't look at your sun, because actually you're going to get damage according on your sun. Now the panels at the present time, and I don't want to pick on manufacturers, is the 12%, 14%, but accounting that under ideal conditions, but taking now into consideration some of the losses associated with that, we find out that some of those things are actually what? Much less than that. So the answer to this gentleman up there, maybe 8, 10%, it's a pretty good number. So we still actually need a lot of work to be done and actually in the manufacturing, actually the processes for the panels. Ideally, what do I want to do? I want to shine what? 1,000 watts per square meter in a panel and get out of it what? 1,000 watts worth of power up there. Then obviously, of course, some of you are going to say, stick a transformer there, step up the voltage in the back of it. Okay. So in the Earth, the irradiance, the amount actually of radiation that I would get in the Earth by shining the sun, it changes throughout the day. And why does that? Because the sun at a certain point in time is what? It's in a different positions, okay? So actually, if I have to look at it physically, I can see that it starts at a certain zero in increments up there, goes higher, and at nighttime decreases and so forth, okay? So what do we say? So if I look the amount of what? Of irradiance that I would get over a period of time, I would do what? I would just combine the whole days, and I said, this is how much what? Of irradiance I got for the whole day. And I can sort of calculate it, and I can measure it, okay? So if we plot it, what are we going to see? We're going to see here, if I plot during the period of time, let's say from sunrise all the way to the sunset, then I will see that actually the amount of sun that I get, it starts very low at sunrise, it reaches a certain peak during the middle of the day, and then it actually drops out because at some point at night we get no sun up here. So I can plot up the watts per square meter, the amount of radiance that I get over a period of time. Okay, remember, the radiation is instantaneous, over a period of time varies because the condition of the sun, and I can measure. So the total of it, it's going to be whatever I have underneath here. And they're using this calculations to come up with some simple things that they can define to you guys, so you can say, okay, I have a certain amount of what? Radiation over a period of time. Now, what type of radiation do I get, okay? Almost all of the radiation that comes from the sun, it's electromagnetic type of radiation, because the properties that it has what? It's typically the electromagnetic radiation is in the form of what? Waves with electrical and magnetic properties. Things are spinning. The particles up there, they're going in a certain speed. And the waves up there, they vary in length depending the type of a source. You heard about gamma rays, beta rays, and wavelength of radiation. The wavelength of the type of radiation determines the properties of radiation that you have. You said, why is this important for us to know? The reason for that is when you get a certain amount of radiation from the sun, and you have a piece of electrical device that you have in here that you call it a module, you have to know this particular module, how susceptible that is to the type of radiation you're getting from the sun. If the module has the capability to absorb all the type of radiation that comes from the sun, then therefore you're going to get what? More power out of it. If it has only a certain type of radiation that it would accept and convert that into energy, then obviously it's got limitations for that. That's the whole concept. So manufacturers are working actually to be able to capture what? The whole spectrum of radiation and convert that to electrical energy. If that is the case, then we'll be able to do what? A lot better in the actually efficiency of our modules up there. So now if you look at the properties now of the electromagnetic radiation that we're getting from the sun, we find out that we have very short wavelength, which is trillions of a meter up there, and which in the form of gamma rays, okay, and they're given out by high energy radiation. So if you have long wavelengths, we're using this for radio transmissions and so forth, and we have ultraviolet radiation, visible light, and infrared radiation. Most of the modules, so now you're going to look at it and you're going to say, well, a lot of the modules that manufacturers manufacture now, since they're using elements from the Earth, they're going to be susceptible to this type of radiation. So you look at modules and say to yourself, well, how good are you when it deals, for example, in the electromagnetic spectrum of an X-ray or infrared radiation? Are you capturing this thing and transform this into energy, or it just goes to waste? That's why they keep on saying the sun has an abundance of energy. If we can only capture it, and we have a way to capture it and utilize it, then we get it for free. That's the whole thing, and that's why you have scientists, you know. Yes, sir?
So which is the spectrum that the modules
okay.
make the most use of?
All right, you went one step up here, so let's look at a picture here. Okay? So when we look at here, for example, and this is the wavelength of each one of them. Here we have the radio waves, the microwave radiation, infrared radiation in here, and this is the visible light, ultraviolet radiation in here, X-ray, gamma rays, and so forth. Okay? So this is the whole spectrum. Ideally, this is everything that comes from the sun. Of all this part. If we can capture those things in here, boy, we're going to have tremendous amount. It sort of happens to, we have the solar guy here. It sort of happens that a lot of the modules in here, they deal with what? All the way from here, from ultraviolet light in here and up to the infrared things. But again, not totally the whole amount of it. So we really actually in this particular band in here that the modules have been more responsive than we have now. If we could capture the whole thing of it, we would have been a much better off with it. All right? Yes?
So in other words, the modules that we need now to install, they need direct sunlight. They don't need daylight. They just need direct sunlight.
They need. Yeah. It doesn't. It could be a cloudy day, and the module will actually give you a voltage. So you actually need the spectrum to have ultraviolet, visible light, and a little bit of infrared radiation.
But the module won't give you as much voltage on a cloudy day as it would.
The module has limitations. Yes. But the ultraviolet, you can have a cloudy day and get ultraviolet, and it would give. The module actually, when we talk about modules, the voltage